So when you're comparing multiple sets of data, you can compare two things. You can compare the location of the data and you can compare the spread of the data. Now you can do this in two ways. Firstly, you can use the mean to compare the location and you can use the standard deviation to compare the spread, or alternatively, you can use the medians to compare the location and you can use the interquartile ranges to compare the spread. Now, something that's really important is do not mix these pairs around. So, for example, do not use the median to compare the location and then use the standard deviation to compare the spread, or vice versa. Only use them in these pairs on the screen here. Use the mean with the standard deviation and use the median with the interquartile range. Don't mix them up. Okay, so here's an example question where we're told the data set X contains the heights in centimeters of 10 boys in class A, and given that sigma X is equal to 1693 and sigma X squared is equal to 287011, for part A we need to find the mean and standard deviation for the data. Okay, so we did a video on standard deviation, so go back to that if you need a reminder of how we calculate it. So let's start with the mean. So the mean, which is given this notation here, is sigma x, so this is all of the data values added together, divided by n, where n is the number of data values. So therefore the mean here is sigma x, which we're told is 1693, divided by n, and we're told that the data set x is the height of 10 boys, so therefore n is equal to 10. So it's 1693 divided by 10, which is equal to 169.3 centimeters. So this is the mean height. And then to find the standard deviation, let's start with the variance. So remember the formula for variance, it's sigma x squared divided by n minus sigma x over n squared. A way you can remember this is it's the mean of the squares minus the square of the mean. So therefore here sigma x squared we're told is 287011 divided by n, which we know is 10, minus sigma x over n, which is the mean, and we calculated the mean to be 169.3, so we can just sub this in, so 169.3, and it's the mean squared. So therefore the variance, if you put this here into your calculator, is equal to 38.61. So therefore the standard deviation is the square root of the variance, so it's the square root of 38.61, which if you put it into your calculator to two decimal places is 6.21 centimeters. So this is the standard deviation. Okay, so we're told the height of 10 boys in class B measured. The mean is 172.4 centimeters and the standard deviation is 8.02 centimeters. And for part B, we need to compare the heights of the boys in class A and class B using this information. Okay, so remember we need to compare two things. We need to compare the location and we need to compare the spread. So let's use the mean for the location. So the mean for class A is 169.3 and the mean for class B is 172.4. So therefore the mean height for class B is higher. So that's the location. So now we need to focus on the spread. So this is the standard deviation. So for class A, it's 6.21, and for class B, it's 8.02. So as the standard deviation is higher for class B, the data is more spread out. So therefore, the heights are more spread out in class B, and that will get you the marks. Okay, so they could ask a question like this in the form of box plots. So here's an example of this where we're told in a school, two classes, Class A and Class B, took the same exam marked out of 20, and their results are represented in the box plots below. And we need to compare the results of the exams for the two different classes, okay? And we're given the box plots here. Now, we did a video on box plots in this chapter already, so go back to that if you need a reminder. Remember, they show the median and the quartile. So unlike before, when we were using the mean and the standard deviation to compare data, this time we're going to use the median and the interquartile range, okay? So to ensure that you get full marks, I would calculate the median and the interquartile range for both of the classes. So if we look at Class A, the median is equal to 12, and then the lower quartile, which we call Q1, is equal to 10, and the upper quartile, which we call Q3, is equal to 14. So therefore the interquartile range is equal to 14 minus 10, which is equal to 4. So the interquartile range is 4 and the median is 12. If we now look at Class B, the median is equal to 7, and then Q1, the lower quartile, is equal to 4, and Q3, the upper quartile, is equal to 11. So therefore the interquartile range is equal to 11 minus 4, which is equal to 7, okay? So therefore, if we can compare the data, let's start with the location, which is the median. So the median for Class A is 12, and the median for Class B is 7. So say Class A has a higher median score, so that's location. So now compare the spread. So the interquartile range for Class A is 4, and the interquartile range for Class B is 7. So therefore Class B has a greater spread of marks, and then that will get you the full marks.